Hello, friend. Some nights the world feels wider than it should, stars breathe slower, time folds in on itself. And if you listen closely enough, not with your ears, but with something deeper, you might notice something strange. The universe is silent, profoundly, impossibly silent. Not the silence of an empty room, but the silence of infinite space where sound has nowhere to go. Tonight we're going to drift through that silence together. We'll explore why the cosmos makes no noise, what that emptiness means, and how the most silent place imaginable might teach us something about rest. You don't need to understand everything, just let yourself settle in. Let curiosity do the listening. Before we begin this journey into the quiet, if you find comfort in these gentle explorations, you might like to stay a while. You can softly tap the like button, subscribe if you'd like more stories told this way, and ring the little bell, not for noise, but so the next quiet night can find you again. Thank you for being here. Now, let's drift. Picture this. You're floating in space far from Earth, far from anything. No spacesuit radio, no spacecraft hum. Just you and the infinite dark. You open your mouth to speak, but nothing happens. Not because you've lost your voice, but because there's nothing for your voice to travel through. Sound as we know it simply cannot exist out there. It's not muffled, it's not faint, it's gone. And in that absence, something remarkable emerges. Pure, unbroken stillness. Scientists tell us that sound is a wave, a vibration that travels through matter. Air, water, steel, even the ground beneath your feet. Molecules bump into each other, passing energy along like whispers in a crowd. But space, for all its grandeur, is almost perfectly empty. Between the stars, there are only a few atoms per cubic meter, sometimes fewer. On Earth, every breath you take contains quintillions of molecules. Out there, you could travel for miles and encounter almost nothing. No molecules means no collisions. No collisions means no sound. The universe in its vastness has created a cathedral of silence. Think about that for a moment. Every explosion, every collision, every cosmic event unfolds in absolute quiet. When a star dies in a supernova, an event so violent it outshines entire galaxies, it makes no sound. The shockwave ripples outward, carrying energy and matter across light years. But there's no roar, no crack, no echo. If you could somehow survive near one, floating in your imaginary spacesuit, you'd see a blinding flash of light, feel the heat, maybe even the push of radiation. But you'd hear nothing, not a whisper. This isn't a flaw in the universe's design. It's simply physics. Sound needs a medium. Space by its nature denies that need. Some might call it lonely. Others might call it peaceful. Perhaps it's both. Astronauts who have worked outside the International Space Station describe this in quiet awe. During spacewalks, they can't talk to each other directly. Their voices don't carry through their helmets into the void. Instead, they rely on radio's electrical signals converted to sound waves inside their suits. One astronaut, Chris Hadfield, once said it felt surreal to watch his crewmate working just a few feet away, moving tools, adjusting equipment completely silent, like watching a film with the sound turned off. The only noise was his own breathing amplified inside his helmet and the faint hiss of oxygen flowing. It's almost dreamlike, isn't it? To be so close to someone and yet exist in separate pockets of sound. In space, you carry your noise with you. Everything else is still. Now, you might wonder, does that mean space is truly empty? Not quite. There's light, of course. Electromagnetic radiation in all its forms, from radio waves to gamma rays, travels freely through the void. Light doesn't need air or matter. It moves through nothingness just fine at 186,000 miles per second, indifferent to the silence. And there are magnetic fields, gravitational waves, particles streaming from the sun. Space is full of information, full of energy. It's just quiet about it. Scientists have tried to imagine what sound in space might be like if it could exist. NASA, for instance, has taken data from space electrical signals, plasma waves, magnetic fluctuations, and converted them into audio frequencies humans can hear. They call it sonification. It's not real sound, of course. It's a translation, a way to make the invisible tangible. When you listen to these recordings, you hear eerie hums, whistles, crackles, the voice of Jupiter's magnetosphere, the song of solar wind. These aren't sounds the universe makes. They're sounds we create from the universe's data, a bridge between silence and comprehension. But the actual cosmos, still silent. There's something humbling in that. We live on a planet drowning in noise. Car engines, conversations, music, wind, rain, the distant bark of a dog. Even in the quietest room, you can hear your heartbeat, your breath, the faint ringing in your ears. Silence. True silence is almost impossible here. But out there beyond our thin blanket of atmosphere, it's the default state. The universe doesn't need sound to exist. It never has. And maybe that's where we can learn something. In our lives, noise often masquerades as importance. The louder something is, the more we think it matters. But the universe operates on a different principle. Gravity doesn't shout. Light doesn't announce itself. Stars burn for billions of years without fanfare. The most powerful forces in existence work quietly, patiently shaping everything without demanding attention. Perhaps silence isn't the absence of something. Perhaps it's the presence of space itself, a kind of cosmic courtesy giving everything room to exist without interference. Here's a question worth sitting with. If you could float in that silence just for a moment, would it frighten you, or would it feel like relief? Some astronauts say the quiet is unsettling at first. Our brains expect sound. We're wired to listen for danger, for connection, for proof that the world is still moving. But after a while, many say the silence becomes comforting. It's a reminder that not everything needs to be explained or heard. Some things simply are. On Earth, we sometimes chase silence. We close doors, turn off devices, seek out quiet places. But we can never quite reach what space offers. There's always something, a hum, a creak, the rustle of fabric. Out there, the silence is absolute. And in that absoluteness, there's a strange kind of peace. The ancient Greeks believed that the cosmos produced a sound, a harmony of the spheres, they called it. Each planet, they thought, sang a note as it moved, creating a celestial symphony too perfect for mortal ears. It was a beautiful idea, even if it wasn't true. But maybe they were onto something. Maybe the universe does have a music, just not one made of sound, the rhythm of orbits, the pulse of starlight, the silent dance of gravity pulling everything together, then pushing it apart. We can't hear it, but we can feel it in a way. In the turning of seasons, in the tides, in the fact that we're here at all tiny specks on a tiny world, held in place by forces we'll never fully grasp. And tonight, as you lie here, letting these thoughts wash over you, consider this. Your body is mostly empty space too. Between your atoms, there's vastness. If you could zoom in far enough, you'd see that you're made of the same silence the universe is. Particles separated by voids held together by invisible forces. You are, in a sense, a small pocket of cosmos, walking around thinking, breathing, dreaming. The silence out there isn't separate from you. It's part of you, always has been. So, maybe just for now, you can stop trying to fill the quiet. You don't need to. The universe has been doing this for billions of years, existing without a single sound, and it's doing just fine. Stars are born, galaxies swirl, time moves forward, all in perfect, unbroken stillness. You can rest in that. You can let the noise of the day fall away, knowing that somewhere out there, the cosmos is doing what it's always done, holding space, keeping time, asking nothing of you. Just breathe. Let your thoughts slow. Let the silence settle around you like a blanket. The universe is vast, yes, but it's also patient. It's been waiting for you to notice this all along. And now that you have, perhaps you can carry a little of that cosmic quiet with you. Not as something to fear, but as something to return to. A reminder that peace doesn't have to be loud, that rest doesn't need permission, that sometimes the most profound truths are the ones whispered in silence. Space doesn't need sound to matter. Neither do you right now. So close your eyes if you haven't already. Let the stars keep their vigil. Let the darkness do its work. You're safe here, held by gravity wrapped in time, breathing in rhythm with a universe that's been silent since the beginning. And maybe that's the real gift of the cosmos. It asks nothing. It simply exists vast and quiet, reminding us that we don't always have to speak or move or prove ourselves. We can just be, the way the stars are, the way the void is, the way you are right here, right now. Enough. But if we pull back from the silence itself and look at where it came from, we find something unexpected. The universe wasn't always this quiet. In its earliest moments, something happened, something so faint, so ancient, that it's still echoing today, hidden in the fabric of space itself. There's a light in the universe that's been traveling for nearly 14 billion years. It's everywhere all at once, filling every corner of space. You can't see it with your eyes. It's too faint, too cold. But it's there, always a gentle glow, left over from the beginning of everything. Scientists call it the cosmic microwave background. Some call it the afterglow of creation. Others call it the oldest whisper the universe ever made. And if you could somehow translate that whisper into sound, it would be the softest hum imaginable. A note so low, so steady that it feels less like music and more like memory. This light doesn't come from stars. It doesn't come from galaxies. It comes from a moment in time when the universe was young, dense, and unimaginably hot. A moment when everything we know, every atom, every particle, every possibility was compressed into a space smaller than you can picture. And then slowly, it began to cool. That cooling left a mark, a signature, a kind of cosmic fingerprint that's been fading ever since, but never quite disappearing. The story begins about 380,000 years after the Big Bang. Before that, the universe was too hot for light to travel freely. Imagine a thick fog but made of energy and particles instead of water. Photons, tiny packets of light, would try to move, but they'd immediately collide with electrons scattering in every direction. The universe was opaque. You couldn't see through it even if you were there to look, but as the universe expanded, it cooled. And at a certain point around 3,000 degrees Kelvin, something remarkable happened. Electrons and protons combined to form the first hydrogen atoms. Suddenly, photons had room to move. The fog lifted. Light for the first time could travel uninterrupted across space. That light is still traveling, right now. Through your room, through your body, through everything. It's been stretched by the expansion of the universe, redshifted into microwave wavelengths, cooled to just 2.7 degrees above absolute zero. But it's the same light, the oldest light in existence. In 1964, two scientists named Arno Penzias and Robert Wilson stumbled upon this light by accident. They were working with a radio antenna in New Jersey, trying to eliminate background noise from their signal. But no matter what they did, there was a persistent hiss, a faint static coming from every direction. They checked the equipment. They cleaned out pigeon droppings from the antenna. Nothing worked. The hiss remained. It took a while to realize what they'd found. That hiss wasn't noise. It was the universe itself, speaking in a frequency too low for human ears, but perfectly detectable with the right instruments. Penzias and Wilson had discovered the afterglow of the Big Bang. They won the Nobel Prize for it, not because they were looking for it, but because they listened when the universe whispered. Since then, we've mapped the cosmic microwave background in extraordinary detail. Satellites like COBE in 1989, WMAP in 2001, and Planck in 2009 have taken pictures of this ancient light, measuring its temperature across the entire sky. And what they found is stunning. The light is almost perfectly uniform. Almost, but not quite. There are tiny variations, tiny fluctuations in temperature less than 1,000th of a degree. These ripples, these imperfections, are the seeds of everything that came after. Galaxies, stars, planets, you. The structure of the universe was written into those ripples, imprinted in light before the first star ever formed. It's like looking at a photograph of the universe when it was a baby, still smooth and featureless, but already carrying the blueprint of what it would become. Now, here's where it gets even stranger. If you could somehow convert the cosmic microwave background into sound, if you could hear it instead of see it, it would sound like white noise. That static you hear when a radio isn't tuned to a station. That faint buzz on an old television screen when there's no signal. About 1% of that static, that everyday noise, is actually the cosmic microwave background leaking into the electronics. You've heard it before without knowing. The universe has been humming in the background of your life all along. But it's not a loud hum. It's not insistent or demanding. It's patient. It's been there for 13.8 billion years, and it'll be there long after we're gone. The universe doesn't need us to notice. It simply is. Scientists describe the CMB as the most perfect blackbody radiation ever observed. That's a term from physics referring to an object that absorbs all light and re-emits it in a very specific way, based purely on its temperature. The CMB fits that pattern almost flawlessly. It's as if the universe in its infancy was the most ideal thermodynamic system imaginable, smooth, balanced, quiet. And yet within that smoothness, there's information, enormous amounts of it. By studying those tiny temperature fluctuations, scientists can map the early universe's density. They can measure how matter was distributed, where it clumped together, where it spread thin. They can trace the formation of the first structures, the first gravitational wells that would eventually pull in gas and dust and become galaxies. The CMB is a map, a time capsule, a message written in light waiting to be read. But here's something most people don't realize. The cosmic microwave background isn't just out there in space, it's here too, right now. Photons from the CMB are passing through you constantly. Billions of them every second streaming through your skin, your bones, your brain. You're bathed in the oldest light in the universe every moment of your life. You just can't feel it. It's too cold, too faint. But it's there. Doesn't that change the way you think about your place in the cosmos? You're not separate from the universe's history. You're part of it. Those photons carry information from a time before, stars before galaxies before anything recognizable. And they're touching you right now as gently as a thought. Some scientists have tried to imagine what the universe sounded like at that moment, 380,000 years after the Big Bang, when the light first broke free. If you could be there floating in that primordial soup, what would you hear? The answer, surprisingly, is something like sound. Not sound in the way we understand it, but pressure waves moving through the hot plasma creating oscillations, ripples. Astrophysicists have even reconstructed these oscillations using data from the CMB. They call it the sound of the Big Bang, though it's more of a deep rumble than anything melodic. The lowest note, the fundamental frequency, would be about 50 octaves below middle C, far too low for human ears. But it's there encoded in the data, a cosmic bass note that set the rhythm for everything that followed. The universe in its earliest moments had a pulse, and we can still measure it even now, billions of years later. Here's a question to sit with. If the universe has been humming this same note for all of time, what does that say about constancy? About patience? So much of our lives is spent chasing change, seeking novelty, trying to make something new happen. But the universe doesn't work that way. It sets a rhythm and holds it for eons without deviation. There's something deeply calming in that. The knowledge that some things don't need to change, some things just are steadily, quietly, forever. One of the most common misconceptions about the cosmic microwave background is that it's a relic of the Big Bang explosion itself. But the Big Bang wasn't an explosion in the traditional sense. It wasn't a bomb going off in space. It was space itself, expanding everywhere at once, carrying energy and matter with it. The CMB is light from the moment when the universe became transparent, not from the initial burst. It's the afterglow, not the fire. Think of it like this. If the Big Bang were a firework, the CMB would be the smoke that lingers in the sky afterward, glowing faintly in the fading light. The firework is long gone, but the trace remains hanging in the air, visible to anyone who knows where to look. And that trace tells us so much. It tells us the universe is flat, not curved. It tells us how much ordinary matter exists, how much dark matter, how much dark energy. It tells us the age of the universe, the rate of its expansion, the distribution of its contents, all from a faint glow barely warmer than the coldest temperature imaginable. The CMB is also proof that the universe had a beginning. Before the 1960s, there were competing theories. Some believed the universe had always existed in a steady state, unchanging. But the discovery of the cosmic microwave background settled the debate. The universe was born. It had a starting point. And that starting point left evidence still glowing faintly in every direction. It's humbling in a way. To know that the universe keeps receipts, that nothing is truly forgotten. Even the earliest moments, the first light, the first cooling, the first atoms, it's all still here recorded in radiation, waiting for us to notice. You might wonder why this matters. Why spend time thinking about ancient light photons from billions of years ago? What does it have to do with sleep, with rest, with the quiet you're seeking tonight? Maybe it's this. The cosmic microwave background reminds us that the universe operates on time scales we can barely comprehend. 13.8 billion years. And in all that time, this light has been traveling patiently without urgency, filling space with a gentle glow. It doesn't rush. It doesn't demand. It simply persists. And maybe that's a lesson worth carrying with you. That patience isn't passive. That quiet persistence is its own kind of strength. That some of the most important things in the universe are the ones that hum softly in the background, unnoticed by most, but essential nonetheless. The universe doesn't shout, it whispers. And if you listen closely enough, if you let yourself settle into the stillness, you might hear it. Not with your ears, but with something deeper. A sense that you're part of something vast, something ancient, something that's been holding steady since the beginning. You're made of atoms that were forged in stars, yes, but you're also surrounded by light that predates those stars, light that was there before anything you recognize. And that light is still here, still moving, still glowing, still reminding the universe of where it came from. So, rest in that. Let the thought settle. You're held by forces older than time, wrapped in light that's been traveling since before the first galaxy formed. You don't have to do anything. You don't have to prove anything. You can just be the way that light just is steady and soft and eternal. The universe's oldest whisper is still echoing, and it's telling you gently that everything is exactly as it should be. But light, even ancient light, only tells part of the story, because woven into the fabric of the cosmos are places where light cannot escape, where silence takes on a weight so profound that even time bends under its pull. There are places in the universe where stars have stopped burning, where galaxies have grown cold, where the light that once blazed for billions of years has finally quietly gone out. These aren't empty spaces. They're full of matter, full of mass, full of gravity. But they make no sound. They emit no light. They simply exist frozen in time, monuments to endings that happened long ago. And yet, even in death, these objects shape the cosmos. Their gravity still pulls. Their presence still matters. Silence, it turns out, doesn't mean powerless. Sometimes the quietest things in the universe are the ones with the most influence. A star's life is a battle against collapse. For millions, sometimes billions of years, fusion in its core generates outward pressure, pushing against the relentless inward pull of gravity. As long as the star has fuel, hydrogen to fuse into helium, helium into carbon, carbon into heavier elements, it holds its shape, it shines, it burns. But eventually, the fuel runs out. And when it does, gravity wins. What happens next depends on the star's mass. Smaller stars, like our Sun, swell into red giants, shedding their outer layers into space, leaving behind a dense core called a white dwarf. These white dwarfs are about the size of Earth, but contain the mass of a star. A teaspoon of white dwarf material would weigh as much as an elephant. They glow faintly, at first radiating leftover heat. But over time, thousands, millions, billions of years, they cool, they fade. Eventually, they become black dwarfs, theoretical objects, so cold and dark they emit no light at all. The universe isn't old enough yet for black dwarfs to exist, but they will someday. Silent, invisible, floating through space like ghosts of stars that once were. Larger stars meet more violent ends. When a massive star exhausts its fuel, it doesn't fade gently. It collapses catastrophically, and the rebound sends shockwaves ripping through its outer layers in a supernova explosion. For a brief moment, the star outshines its entire galaxy. But after the fireworks, what's left is even stranger. A neutron star, a sphere only about 12 miles across, but so dense that a single sugar cube-sized chunk would weigh as much as a mountain. Neutron stars spin. Fast. Some rotate hundreds of times per second, sending out beams of radiation like cosmic lighthouses. We call them pulsars. From Earth, we can detect those pulses with radio telescopes' rhythmic ticks arriving with clockwork precision. But the star itself makes no sound. It spins in perfect silence, a dead remnant of something that once burned bright. And then there are black holes. If a star is massive enough, not even a neutron star can form. Gravity crushes the core beyond any known limit, compressing it into a point of infinite density called a singularity. Around that singularity, space itself warps so severely that nothing, not even light, can escape. This boundary is called the event horizon. Cross it, and you're gone. Not destroyed exactly, just removed from the universe, pulled into a place where the rules of physics as we know them no longer apply. Black holes are often described as cosmic vacuum cleaners, sucking up everything nearby. But that's not quite right. They don't suck. They don't pull any harder than a star of the same mass would. If the sun suddenly became a black hole without gaining or losing, mass Earth's orbit wouldn't change. We'd still circle it just in the dark. What makes black holes unique isn't their gravitational strength. It's their compactness. All that mass concentrated in an impossibly small space. That's what creates the event horizon, the point of no return. And inside that horizon, time itself behaves strangely. For someone falling in time would appear to flow normally, but for someone watching from a distance, the person falling would seem to slow down, freeze, never quite reaching the edge, suspended forever on the edge of oblivion. Black holes emit no light. They produce no sound. They're the ultimate expression of silence. And yet, paradoxically, they're among the most influential objects in the universe. Supermassive black holes sit at the centers of most galaxies, including our own Milky Way. Sagittarius A. The black hole at our galaxy's heart has a mass of about 4 million suns. It anchors the galaxy, holding billions of stars in orbit around it, a silent gravitational throne. In 2019, scientists captured the first image of a black hole's shadow using the Event Horizon Telescope. It wasn't a photograph in the traditional sense. It was data from radio telescopes around the world, combined to create a single image. What they saw was a glowing ring of light matter swirling around the black hole, heated to billions of degrees surrounding a dark circle, the event horizon, the point where light gives up. That image was of M87 Faust, a supermassive black hole in a galaxy 55 million light-years away. The black hole itself is invisible, of course, but its presence is undeniable. It bends, light bends, space bends time. A monument to gravity's ultimate victory. Here's something that might surprise you. Black holes, for all their reputation, are not eternal. Stephen Hawking discovered in the 1970s that black holes slowly evaporate through a process called Hawking radiation. Quantum effects near the event horizon cause particles to appear, and occasionally one escapes while the other falls in. Over unimaginable spans of time, trillions upon trillions of years, the black hole loses mass, shrinks, and eventually vanishes in a final burst of energy. Even the most permanent things, it seems, are temporary. Even silence has an expiration date. But let's return to white dwarfs for a moment. These objects represent the end state for most stars in the universe. Our sun will become one about 5 billion years from now. When it does, it will cool slowly, taking longer than the current age of the universe to fade completely. White dwarfs are patient in their dying. They don't rush. They simply radiate heat into space degree by degree until there's nothing left to give. Some white dwarfs aren't alone. They exist in binary systems orbiting another star. And if that companion is close enough, the white dwarf can pull matter from it, accumulating mass on its surface. When enough matter builds up, it ignites in a thermonuclear explosion called a nova. The white dwarf survives, but it flares briefly, brightening in the night sky before fading again. And if the white dwarf accumulates too much mass, crossing a threshold called the Chandrasekhar limit, about 1.4 times the mass of the Sun, it can't hold itself together anymore. It collapses, ignites, and tears itself apart in a type Ia supernova. These explosions are so consistent in brightness that astronomers use them as cosmic yardsticks, measuring distances across the universe. Even in death, stars serve a purpose. Even in silence, they teach us about scale, about time, about the mechanics of the cosmos. There's a poetic irony here, isn't there? The brightest explosions in the universe come from objects that were already dead. The loudest events of sound could travel through space, arise from stars that had long since stopped burning. Endings, it seems, can be as dramatic as beginnings. Sometimes more so. But most stellar remnants don't explode again. They simply drift, cooling, fading, becoming part of the background. Neutron stars spin in silence. White dwarfs glow faintly, then not at all. Black holes bend space without fanfare. The universe is littered with these quiet monuments, evidence of processes that played out over eons, written in matter too dense to imagine. And here's a thought worth holding. These dead stars still have gravity. They still curve space-time. They still influence the orbits of anything nearby. They're silent, yes, invisible often, but their presence is felt. They don't need to shine to matter. Isn't that true of many things? The most important forces in our lives aren't always the loudest. Grief, memory, love. They work quietly, shaping us without announcement. We carry them the way the universe carries its dead stars, invisible but ever present, bending the paths we take. Scientists estimate there are about 100 billion white dwarfs in our galaxy alone. Maybe 10 billion neutron stars. Perhaps 100 million black holes. That's a lot of silence, a lot of endings, a lot of things that were once bright, once loud in their own way, now resting in stillness. And yet the universe doesn't mourn them. It doesn't need to. They played their part. They fused hydrogen into helium, into carbon, into oxygen, nitrogen, iron. They created the elements that make up planets, oceans, life. And when they finished, they stepped aside, letting the next generation of stars take over. There's something deeply restful in that cycle. Birth, life, death, return. No waste, no permanence. Just transformation over and over in a universe that knows how to let go. Perhaps that's the real lesson of dead stars. That endings aren't failures, they're transitions. The energy doesn't disappear, it changes form. A star becomes a white dwarf, becomes a black dwarf, or a neutron star, or a black hole. The atoms it created scatter into space, seeding new stars, new worlds. Nothing is truly lost. It just gets quieter. Think about the black hole at the center of our galaxy. Sagittarius AI. 4 million solar masses compressed into a region smaller than Mercury's orbit. It's been there for billions of years, silent, invisible, holding the Milky Way together. Every star in our galaxy, including the Sun, orbits it. We're all tied to that silence, whether we realize it or not. And on a smaller scale, think about the white dwarfs scattered through our night sky. Some of the stars you see, faint, distant, steady, are white dwarfs, remnants of stars that died long ago. They're still contributing to the light we see, still part of the cosmic landscape, still here in their own quiet way. You might wonder what it would be like to visit one of these objects, to float near a white dwarf, feeling its residual heat, to orbit a neutron star, watching it spin impossibly fast. To approach a black hole feeling space-time stretch and warp around you, it's hard to imagine. These places are so far outside our everyday experience that they feel almost fictional, but they're real, and they're silent, profoundly, deeply silent. One more thing. Neutron stars. Despite being dead, sometimes have companions. If another star is close enough, the neutron star can pull matter from it, accumulating material on its surface. Occasionally, this material ignites in an X-ray burst, releasing as much energy in a few seconds as the sun does in a week. But between bursts, the neutron star is quiet, patient waiting. Even in death, these objects are capable of sudden brilliance. But only occasionally. Most of the time, they're content to exist in stillness, spinning, cooling, holding their shape against the void. And perhaps that's what we can learn from them. That rest isn't the absence of power. That silence isn't weakness. That even when the burning stops, when the light fades, there's still gravity, still influence, still presence. The universe is full of things that no longer shine, but still matter. And maybe in your own life, you carry some of those too. Memories that don't speak, but still shape you. Losses that don't announce themselves, but still hold weight. Moments that ended, but never quite left. They're part of you the way dead stars are part of the galaxy. Quiet, invisible, essential. So, rest in that knowledge. You don't have to be bright to be important. You don't have to make noise to have presence. You can be still and silent and exactly where you need to be. The universe has been practicing this for billions of years, letting stars die, letting silence take over, letting gravity do its work without spectacle, and it's doing just fine. Yet there's another kind of silence written into the cosmos, one that comes not from death, but from distance, a loneliness so vast that even light struggles to cross it. Imagine sending a message to someone and waiting 4 years for them to receive it. Not 4 hours, not 4 days, 4 years. And then, if they replied immediately, another 4 years before you heard back. That's the reality of communicating with our nearest stellar neighbor, Proxima Centauri, a small red dwarf just over 4 light-years away. In cosmic terms, that's close, practically next door. But in human terms, it's an unbridgeable gulf, a silence enforced not by emptiness, but by the sheer scale of space itself. Distance in the universe doesn't just separate objects, it isolates them. It wraps them in layers of time so thick that connection becomes almost meaningless. And in that isolation, there's a profound kind of quiet. Not the quiet of sound's absence, but the quiet of unreachable separation. Let's start with something familiar, the sun. It sits at the center of our solar system, 93 million miles from Earth. Light from the sun takes 8 minutes and 20 seconds to reach us. That means, when you look at the sun, please don't actually look directly at it. You're seeing it as it was 8 minutes ago, not as it is now. The present sun, the one existing in this exact moment, is invisible to you. You can only see its past. If the sun suddenly vanished, blinked out of existence in some impossible cosmic accident, we wouldn't know for 8 minutes and 20 seconds. We'd still see its light. We'd still feel its warmth. We'd still orbit a star that no longer existed. And then all at once the light would stop. Darkness would arrive. Gravity would release us. Earth would drift into the void, following a straight line into the cold. But the sun won't vanish, of course. It's been burning steadily for 4.5 billion years, and it has another 5 billion to go. Still, the thought experiment reveals something important. Distance creates delay, and delay creates a kind of silence, a gap between cause and effect, between here and there, between now and then. The nearest star system to us, Alpha Centauri, is actually a triple star system. 3 stars orbiting each other, bound by gravity. The closest of the 3, Proxima Centauri, is 4.24 light-years away. If we sent a radio signal traveling at the speed of light, the fastest anything can go, it would take 4.24 years to arrive. And if someone was there to receive it and respond, Their reply would take another 4.24 years to return. That's 8.48 years for a single exchange. A conversation spanning nearly a decade. By the time you got an answer, you might have forgotten the question. Now consider this. The Voyager 1 spacecraft, launched in 1977, is the farthest human-made object from Earth. As of now, it's about 15 billion miles away, traveling through interstellar space at roughly 38,000 miles per hour. That sounds fast, but at that speed, it would take Voyager 1 over 70,000 years to reach Proxima Centauri. 70,000 years, longer than human civilization has existed. And when Voyager 1 sends a signal back to Earth, that signal traveling at light speed takes over 22 hours to arrive, nearly a full day. Mission controllers send a command, wait a day, and hope the spacecraft received it. There's no real-time communication, only patient-delayed exchanges across a void so large it swallows time itself. Voyager 1 carries a golden record, a disk containing sounds and images from Earth. Music greetings in 55 languages, natural sounds like whale songs and thunder. It's a message in a bottle thrown into the cosmic ocean, but the chances of it ever being found are almost zero. Space is too vast. The silence between stars is too deep. And yet, we sent it anyway. A gesture of hope or perhaps defiance against the loneliness of the universe. Here's where it gets even stranger. The light we see from distant stars isn't just delayed. It's old, ancient. When you look at a star 10 light years away, you're seeing it as it was 10 years ago. A star 100 light years away shows you its light from a century past. Some of the stars you see in the night sky may no longer exist. They could have exploded, collapsed, gone dark, and we wouldn't know. Their light is still traveling toward us, carrying news that's already outdated by the time it arrives. The universe doesn't give us the present, only the past delivered slowly wrapped in photons that have been journeying for years, centuries, millennia. The Andromeda Galaxy, our nearest large galactic neighbor, is 2.5 million light years away. When you look at Andromeda, you're seeing it as it was 2.5 million years ago. Back when early humans were just beginning to use stone tools. Back when the world was colder, wilder, unrecognizable. The light from Andromeda left its stars before modern humans existed, traveled through the emptiness of intergalactic space, and finally arrived here now for you to see. But what's happening in Andromeda right now? You'll never know. Not in your lifetime, not in 1,000 lifetimes. The information is traveling toward us, yes, but it won't arrive for another 2.5 million years. By then, everything you know will be dust. This is the tyranny of distance. The universe is so large that simultaneity becomes meaningless. Now is a local concept. It doesn't extend beyond your immediate surroundings. Out there in the space between galaxies, there is no shared present. Only layered pasts stacked like pages in a book you can never finish reading. Scientists estimate there are about 2 trillion galaxies in the observable universe. 2 trillion islands of stars, each containing hundreds of billions of suns, separated by vast stretches of mostly empty space. The distances between galaxies are measured in millions or billions of light years. The time it takes light to cross those gaps is longer than species exist. Longer than civilizations rise and fall. If there's another intelligence out there, another civilization looking up at their night sky and wondering if they're alone, we might never know. Even if they sent us a message traveling at light speed, it could take so long to arrive that neither their civilization nor ours would still exist to receive it. The universe is full of potential voices, potential connections, potential conversations. But the distances silence them, not because sound can't travel through space, though it can't, but because light itself, the fastest messenger we have, is too slow for the scale of the cosmos. Carl Sagan once described Earth as a pale blue dot, a tiny pixel suspended in a sunbeam, photographed by Voyager 1 from 4 billion miles away. He wrote about how that image captures our insignificance, our isolation. The fact that everything we've ever known exists on that dot alone in the dark. But there was tenderness in his words, too. A recognition that our loneliness makes us precious, that the silence surrounding us makes the sounds we create matter more. Here's a question to sit with. Does distance diminish connection, or does it make connection more meaningful? When you reach out across a void that large, when you send a message knowing you'll never hear back, what does that say about hope, about persistence, about the refusal to accept silence as the final word? The distance between objects in space is growing. The universe is expanding, and that expansion is accelerating. Galaxies are moving away from each other, carried by the stretching of space itself. In billions of years, the galaxies beyond our local group will recede so far that their light will no longer reach us. They'll disappear beyond the cosmic horizon, not because they stopped existing, but because the space between us grew too large for light to cross. Future civilizations, if they arise, will look up at a lonelier sky. Fewer stars, fewer galaxies, less light. They'll inherit a universe where isolation is even more profound, where the evidence of a larger cosmos has faded into the dark. But that's far in the future. Right now, we can still see those distant galaxies. We can still measure their light, calculate their distances, map their positions. We can still marvel at how far light has traveled to reach our eyes, carrying stories from places we'll never visit, times we'll never experience. There's a name for this phenomenon, the way distance layers time. It's called the look-back time. When you observe something far away, you're not just seeing across space, you're seeing across time. The deeper you look into the universe, the further back in history you see. The most distant galaxies visible to us appear as they were over 13 billion years ago, shortly after the Big Bang. They're not there anymore, not in that form. They've evolved, changed, perhaps even died. But their light is still arriving, still showing us what was. The universe is a museum of its own history written in light. And yet, despite all this vastness, all this distance, we're connected to it. The atoms in your body were forged in stars that died billions of years ago. The oxygen you breathe, the calcium in your bones, the iron in your blood, all of it came from stellar explosions scattered across the galaxy, carried by light and dust and gravity until it condensed into planets, into oceans, into life. You are made of distance. You are made of time. You are the universe's way of looking back at itself across billions of years and finding something worth preserving. So, even though the silence of space is profound, even though the distances are unbridgeable, even though the isolation is absolute, you're not separate from it. You're part of it. A small, temporary arrangement of atoms that once traveled light years through the void, gathering here now, in this moment, aware of itself. And maybe that's enough. Maybe the silence doesn't need to be broken. Maybe the distance doesn't need to be crossed. Maybe it's enough to know that somewhere out there light is still traveling. Messages are still moving. Connections are still possible even if we never witness them. The universe teaches patience in this way. It operates on timescales that dwarf our lives, distances that humble our ambitions. And yet it persists. Light keeps moving. Gravity keeps pulling. Time keeps passing. The cosmos doesn't rush. It doesn't need to. Neither do you. So, let yourself rest in that knowledge. You don't have to reach across the void tonight. You don't have to answer questions light years away. You can just be here small and quiet, held by gravity wrapped in time, breathing in atoms that once were stars. The universe is patient with you. And you can be patient with yourself. But if distance creates one kind of silence, there are places where silence takes on an even stranger quality. Worlds without air, without atmosphere, where even the possibility of sound has been stripped away. There are worlds in our solar system where footsteps leave marks that will last for millions of years, where meteorites strike the surface without a whisper, where the sun rises in complete silence and sets the same way. These aren't distant exoplanets orbiting alien stars. They're right here neighbors in our cosmic backyard, worlds without air, without wind, without the possibility of sound. On these silent planets and moons, you could stand next to an erupting volcano and hear nothing. You could watch rocks tumble down a cliff face in perfect quiet. Your own heartbeat would be the only sound in your universe, trapped inside your spacesuit, unreachable by the world outside. This is what absolute silence looks like. Not the silence of space between stars, but the silence of solid ground beneath your feet, ground that will never carry a whisper. Our moon is the most familiar example. Humans have walked there. We've left footprints, planted flags, driven rovers across its dusty surface. And all of it happened in total silence. When Neil Armstrong took his first step on July 20th, 1969, his boot pressing into lunar regolith, there was no crunch, no rustle, no sound at all except what he could hear inside his helmet. His own breathing, the hum of his life support system, the crackling radio transmissions from Earth. The moon has no atmosphere, no air molecules to carry vibrations, no medium for sound to travel through. Armstrong and Buzz Aldrin worked side by side, sometimes just feet apart, but they couldn't speak to each other directly. They relied entirely on radio. Without it, they would have been completely isolated, sharing the same silent landscape, but unable to bridge the gap between them. Think about that for a moment. Two people standing on another world, surrounded by the same rocks, the same dust, the same harsh sunlight, and yet separated by an invisible wall of silence. They could see each other, they could reach out and touch, but their voices couldn't carry. The moon swallowed all sound before it could begin. The footprints they left are still there, preserved perfectly in the airless environment, unmarked by wind or rain or erosion. Someday, perhaps centuries from now, someone might visit those sites and see the same prints exactly as they were left. A silent record of a moment when humanity first stepped into the cosmos. But the moon isn't unique in its silence. Mercury, the closest planet to the sun, has no atmosphere to speak of. Just a thin exosphere, a barely there layer of atoms knocked off the surface by solar wind. During the day, Mercury's surface reaches temperatures of 800 degrees Fahrenheit. At night, it plunges to minus 290. Extreme swings, violent conditions, and yet perfectly quiet. If you stood on Mercury's scorched plains, watching the enormous sun hang in the black sky, you'd hear nothing. Not the crackle of heat. Not the impact of micrometeorites. Nothing. The silence on airless worlds isn't peaceful the way we think of peace. It's stark, unforgiving. It's the silence of a place that doesn't care whether you're there or not, that offers no acknowledgement of your presence. On Earth, we're used to environments responding to us. Our voices echo, our footsteps thud. The world confirms that we exist. But on the moon, on Mercury, on any airless body, that confirmation vanishes. You move through the landscape like a ghost, leaving no acoustic trace. Scientists who study these environments have noted something interesting. The absence of sound changes how humans perceive reality. Astronauts on the moon reported feeling disconnected, almost dreamlike, as if they were watching themselves from outside their own bodies. Without auditory feedback, the brain struggles to place you in the scene. You're there, but you don't feel fully anchored. The world feels less real. Sound, it turns out, is more than just information. It's grounding, it's connection. Without it, even solid ground beneath your feet can feel uncertain. Now, let's travel farther out. To Europa, one of Jupiter's moons. Europa is different from the moon or Mercury. It has an icy surface frozen hard as rock, but beneath that ice, maybe 10 to 15 miles down, scientists believe there's a global ocean. Liquid water kept warm by tidal heating from Jupiter's immense gravity. That ocean might contain more water than all of Earth's oceans combined. But the surface of Europa is silent, airless, frozen. If you stood there, you'd see Jupiter looming overhead, massive and striped, filling half the sky. You'd see the ice stretching out in every direction, fractured into chaotic terrain ridges and cracks crisscrossing like scars. And you'd hear nothing. Not the creak of shifting ice, not the rumble of subsurface movement, just silence. Beneath you, though, in that hidden ocean sound could exist. Water carries sound beautifully. Better than air, in fact. If there's life in Europa's ocean microbes, perhaps, or something stranger, they might communicate through sounds sending vibrations through the water, the way whales do on Earth. But you standing on the surface would never hear it. The ice would block everything. Two worlds, one silent one, potentially full of noise, separated by a barrier you can't cross. Here's a question worth considering. What would it feel like to know that sound exists so close to you, but forever out of reach? To stand on a world where life might be singing, calling, communicating, all just a few miles beneath your feet, and yet, you'll never hear a note of it. That's the cruelty of airless worlds. They don't just lack sound, they create barriers between you and the possibility of sound. They isolate you in ways that go beyond distance. Mars is a borderline case. It does have an atmosphere, but barely. The air pressure on Mars is less than 1% of Earth's, thinner than the edge of space as we define it. If you tried to breathe Martian air, your lungs would find almost nothing, and sound. It travels but weakly. Very weakly. NASA's Perseverance rover, which landed on Mars in 2021, carried microphones. For the first time, we were able to hear what Mars sounds like. The recordings are eerie. The rover's wheels crunching over rocks sound muffled distant like they're happening underwater. The wind, when it blows, is barely audible, a faint whisper, instead of the roar you'd expect. Sounds that would be sharp and clear on Earth are dulled, softened, almost swallowed by the thin air. On Mars, even when sound exists, it's struggling, fighting against an atmosphere that's too weak to carry it properly. It's a world caught between silence and noise, belonging fully to neither. But let's return to true airless worlds. There's something almost philosophical about them. They force us to confront what sound really is. We take it for granted on Earth. We assume that if something moves, it makes noise. That if something falls, crashes, explodes, we'll hear it. But sound isn't an inherent property of events. It's a consequence of medium. It requires matter to move through molecules to bump into each other, air or water or ground to carry vibrations. Without that medium, events happen in silence. Not because they're small or far away, but because there's nothing to translate their motion into something ears can detect. The largest impact crater on the Moon, the South Pole Aitken Basin, is over 1,500 miles wide and 8 miles deep. It was created by an asteroid impact so violent it excavated material from deep within the Moon's crust, possibly even reaching the mantle. The energy released would have been unimaginable. Enough to vaporize rock to send shockwaves rippling across the lunar surface to reshape the Moon's geography. And it made no sound, not a whisper, not a rumble. The impact happened, the Moon shook, and the universe noticed nothing. That's the reality of airless worlds. Catastrophic events unfold in silence. The most violent processes in the solar system, impacts, eruptions, landslides can happen without a single sound reaching beyond the point of collision. The energy goes into heat, into motion, into light, but never into sound because there's nowhere for sound to go. There's a lesson in that, perhaps. That significance doesn't require announcement, that some of the most important events happen quietly, without fanfare, without anyone hearing them. The Moon was shaped by impacts we'll never hear. Europa's ocean might teem with life we'll never detect. Mercury endures its temperature swings in perfect stillness. And the universe doesn't care. It doesn't need our acknowledgement to continue. On Earth, we mark moments with sound. Bells ring for celebrations. Alarms blare for danger. Music accompanies emotion. We've built entire cultures around auditory signaling, around the idea that important things should be loud. But airless worlds remind us that the universe doesn't work that way. Most of what happens in the cosmos happens silently, and it matters just as much. Imagine being an astronaut on the Moon, looking back at Earth, that blue marble hanging in the black sky, glowing softly alive with clouds and oceans, and continents. You know that down there the world is full of sound, waves crashing, wind howling, birds singing, billions of voices speaking, laughing, crying. All of it happening right there just 240,000 miles away. Close enough to see, close enough to reach in a few days. But you can't hear any of it. The distance doesn't matter. The lack of air does. You're standing on a world that will never carry Earth sounds to you, no matter how loud they are. You're isolated not by distance, but by the nature of the ground beneath your feet. And yet, there's a strange beauty in that isolation. The silence forces you to pay attention differently. Without sound to distract you, you notice other things. The way light plays across the lunar surface, the texture of the dust, the sharpness of shadows unblurred by atmosphere, the overwhelming presence of the stars, brighter and more numerous than you've ever seen. On Earth, we rarely experience true silence. Even in the quietest places, there's always something. The hum of electronics, the rustle of leaves, the distant drone of traffic. But on the moon, on Mercury, on any airless body, silence is absolute. And in that absoluteness, there's clarity, a kind of purity. The world stripped down to essentials light shadow, matter void. Nothing extra, nothing unnecessary. Just existence in its simplest form. The Apollo astronauts described this in their debriefings. They talked about the stillness, the sense of being in a place untouched by time. Some found it unsettling, others found it meditative, but all of them agreed that it changed them, that standing in a place without sound made them see the world and themselves differently. Perhaps that's what airless worlds offer us. Not comfort, but perspective. A reminder that the universe doesn't need sound to function. That silence isn't emptiness, that some of the most profound experiences happen in the quiet spaces between noise. And maybe we can carry that lesson with us, that we don't always need to fill the silence, that it's okay to let moments pass without commentary, without soundtrack, without the need to announce our presence. We can simply be the way the moon is, the way Mercury is, the way all those silent worlds are. Steady, quiet, enough. Let your breath slow. Let the thoughts settle. You're here in this moment, held by a planet that does have air, that does carry sound, but that also knows how to be still. And perhaps tonight you can practice that stillness. You can let the world fall silent around you, knowing that silence isn't absence. It's presence in its most essential form. The moon has been silent for 4.5 billion years, and it's doing just fine. So can you. Yet beyond these silent surfaces, beyond even the reach of light itself, lies a boundary where the universe becomes unknowable, a place where information stops, where even our most fundamental questions dissolve into the dark. There's a horizon in the universe that has nothing to do with Earth. It's not the line where the sky meets the ground or where ocean touches atmosphere. It's a boundary drawn by time itself, a wall built from the speed of light and the age of the cosmos. Beyond that boundary, information cannot reach us. Not because it doesn't exist, but because it hasn't had time to arrive. This is the edge of the observable universe, not the edge of the universe itself that may be infinite, or it may loop back on itself, or it may have some other shape we can't yet comprehend. But the edge of what we can see, what we can know, what we can ever hope to detect. Beyond that edge lies a silence more absolute than any we've discussed. The silence of the unknowable. Let's start with what we can observe. The observable universe is a sphere centered on Earth, extending about 46.5 billion light years in every direction. That number might seem strange at first. The universe is only 13.8 billion years old, so shouldn't light have traveled only 13.8 billion light years? The answer lies in expansion. While light has been traveling toward us for 13.8 billion years, the space it's traveling through has been stretching. By the time the light reaches us, the object that emitted it is much farther away than it was when the light began its journey. This creates a kind of cosmic horizon, Light from objects beyond that horizon simply hasn't had time to reach us yet. And because the universe is expanding, accelerating, even some of that light never will. The space between us and those distant objects is stretching faster than light can cross it. They're receding beyond our reach, slipping into a realm we'll never access. Imagine standing on a beach watching waves approach, but the beach is stretching, growing longer, faster than the waves can travel. Eventually, the waves stop reaching you, not because they stopped moving, but because the distance grew too large. That's what's happening at the edge of the observable universe. Light is still trying to reach us, but the expansion of space is winning. In 1929, astronomer Edwin Hubble made a discovery that changed our understanding of the cosmos. He observed that distant galaxies were moving away from us, and the farther they were, the faster they receded. This wasn't because they were physically moving through space, but because space itself was expanding, carrying them along. Hubble's discovery provided the first evidence that the universe had a beginning, that it was born in a moment of rapid expansion we now call the Big Bang. But Hubble couldn't have known then just how profound the implications were. The expansion he measured wasn't slowing down as many expected. In 1998, two teams of astronomers studying distant supernovae discovered something shocking. The expansion of the universe was accelerating. Something they called it dark energy was pushing space apart faster and faster. This acceleration has consequences. It means that galaxies beyond a certain distance will eventually cross a threshold where their light can never reach us. They will still exist, still shine, still evolve. But from our perspective, they'll vanish. Fade into the dark, not destroyed, just unreachable, hidden beyond a boundary that grows with time. The observable universe is shrinking in a sense, or rather, it's becoming lonelier. The portion of the cosmos we can interact with is getting smaller, not because we're losing anything, but because the universe is pulling itself apart. Right now, we can see about 2 trillion galaxies. 2 trillion islands of stars, each containing hundreds of billions of suns scattered across the observable universe. But in the far future, trillions of years from now, any civilization that arises will see far fewer. Most of those galaxies will have drifted beyond the horizon, their light stretched and redshifted into invisibility. Future beings might look up at a nearly empty sky and conclude they're alone, unaware that they're surrounded by galaxies they simply cannot see. It's a humbling thought. The evidence of the universe's vastness is temporary. We're living in a special time, cosmically speaking, when the universe is still young enough that we can see its full history, its full structure. We can observe the afterglow of the Big Bang map. The distribution of galaxies measure the expansion rate, but that window is closing. Slowly, yes, but inevitably. Here's a question to sit with. If there are parts of the universe we can never see, never reach, never know, do they still matter to us? Does the silence beyond the horizon diminish what we have, or does it make the visible universe more precious? The edge of the observable universe isn't a physical wall. There's no barrier, no membrane, no place where space ends. It's purely informational. A limit on what can reach us, what we can detect, what we can include in our understanding of reality. And that limit shifts with time, as the universe ages, light from more distant objects reaches us. The observable universe grows, revealing new galaxies, new structures, new corners of the cosmos. But there's a catch. At the same time, expansion is pushing other objects away out of reach. The observable universe is both growing and shrinking, gaining new information, while losing access to old. It's a dynamic boundary shaped by forces far beyond our control. One of the most common misconceptions about the observable universe is that we're at the center. It looks that way, a sphere extending equally in all directions with Earth at the middle. But that's an illusion of perspective. Every point in the universe is the center of its own observable sphere. An observer in a galaxy 10 billion light-years away would see a different observable universe, one that includes regions we can't see and excludes regions we can. There's no universal center, no privileged location. Every observer has their own horizon, their own slice of the cosmos. This means there are galaxies out there that we can see but that can't see us. Our light hasn't reached them yet. And there are galaxies that can see us but that we can't see because their light hasn't arrived here. The universe is full of these one-way relationships, information moving, but not yet connected messages in transit across the void. Scientists estimate that the true universe, the totality of everything that exists, is much larger than the observable portion. How much larger, we don't know. It could be hundreds of times bigger. It could be infinite. The math allows for both possibilities. Some models suggest the universe curves back on itself, like the surface of a sphere, finite but unbounded. Others suggest it's flat, stretching infinitely in all directions. We simply don't know. And here's the thing. We may never know. If the universe is infinite, there's no way to confirm it. We can only observe our finite horizon. Everything beyond is speculation informed by theory, but untested by observation. The silence beyond the edge isn't just a lack of sound. It's a lack of information, of certainty, of proof. In a way, the edge of the observable universe represents the limit of science itself. Science requires data, observation, evidence. But if something is fundamentally unobservable, permanently beyond our reach, can we say anything meaningful about it? Or do we accept that there are questions the universe won't answer? Not because we lack the tools, but because the information doesn't exist within our light cone. The light cone is a concept from relativity. It represents all the events in space-time that can be causally connected to a given point. Everything inside your past light cone could have influenced you. Everything inside your future light cone you could influence. But events outside your light cone are disconnected. No signal, no force, no information can bridge the gap. The observable universe is in a sense the past light cone of Earth, the collection of all events whose light has had time to reach us. And there's poetry in that. The universe you see isn't the universe as it is now. It's the universe as it was layered across time, the moon as it was a second ago, the sun as it was 8 minutes ago, the nearest stars as they were years ago, distant galaxies as they were billions of years ago, the edge of the observable universe as it was 13.8 billion years ago, just after the Big Bang. You're not looking across space, you're looking across time. The deeper you see, the further back you go. The observable universe is a timeline, not a snapshot. Now, consider this. If the universe is infinite, then somewhere far beyond our horizon, there could be anything. Other galaxies, other structures, perhaps even other regions with different physical laws shaped by different initial conditions. Multiverse theories suggest this is possible, though unprovable. The silence beyond the edge could hide wonders we can't imagine. Or it could be more of the same galaxies and stars and planets extending forever. We'll never know. And maybe that's okay, because here's the lesson hidden in the observable universe's edge. Not everything needs to be known. Not every question needs an answer. Some mysteries are meant to remain mysteries, not because they're unimportant, but because their unknowability is part of what makes the universe profound. We live in a cosmos that's larger than our grasp, older than our comprehension, more complex than our models. And instead of frustration, maybe we can feel wonder. The universe doesn't owe us transparency. It doesn't need to fit inside our understanding. It can be vast and strange and forever partially hidden. And that's part of its beauty. The edge of the observable universe reminds us of our limitations. But it also reminds us of our potential. Every tool we build, every telescope we launch, every theory we refine, pushes that edge a little farther. We see deeper, look back further, uncover more of the cosmic story. We may never see everything, but we keep trying. Not because we expect to finish, but because the pursuit itself is meaningful. There's something deeply human in that. The refusal to accept silence as the final answer. The willingness to reach into the unknown, knowing we'll never reach all of it. We're curious beings on a curious planet, looking out into a universe that rewards curiosity with endless questions. And maybe that's enough. Maybe the journey toward the horizon matters more than reaching it. Maybe the silence beyond the edge is a gift, not a limitation, a reminder that there's always more, always something beyond what we know, always a reason to keep wondering. So, let yourself rest in that uncertainty tonight. You don't need to know everything. You don't need to see to the end of the universe. You can settle into the here and now, this small pocket of space and time that you inhabit, and find peace in the knowledge that the cosmos is larger than you, older than you, and perfectly content to keep some of its secrets. The universe has been expanding for 13.8 billion years, carrying galaxies beyond our reach, hiding wonders behind a horizon we'll never cross. And it's doing just fine, so can you. But there's another kind of silence woven through the cosmos, one that doesn't come from distance or time, but from the very substance of the universe itself, an invisible presence so vast it makes up most of what exists, yet speaks not at all. Most of the universe is invisible, not distant, not hidden behind dust clouds or galaxies, just invisible. You can't see it, you can't touch it, you can't detect it with any instrument designed to measure ordinary matter. And yet, it's there, everywhere, passing through you right now, through this room, through the Earth itself, completely indifferent to everything it encounters. Scientists call it dark matter and dark energy. Together they make up about 95% of the universe. Everything you can see, stars, planets, nebulae, galaxies, light, itself is only 5%. 5%. The rest is silence. Not the silence of empty space, but the silence of something present, something influential, something absolutely essential that simply refuses to speak. This is the deepest mystery in modern cosmology. The universe is mostly made of things we don't understand, have never seen, and can only detect through their gravitational effects. It's as if the cosmos is built on a foundation we can't perceive, held together by invisible hands. Let's start with dark matter. The story begins in the 1930s with a Swiss astronomer named Fritz Zwicky. He was studying the Coma Cluster, a collection of over 1,000 galaxies bound together by gravity. Zwicky measured how fast the galaxies were moving and calculated how much mass would be needed to keep them from flying apart. The answer shocked him. The visible matter, all the stars and gas he could see, was nowhere near enough. The galaxies were moving too fast. They should have escaped each other's gravity long ago. Zwicky proposed something radical. There must be matter we can't see, he said. Matter that doesn't emit light, doesn't absorb light, doesn't interact with electromagnetic radiation at all. He called it dark matter. His colleagues dismissed the idea. It seemed too convenient, too much, like making up an invisible substance to solve a problem. But Zwicky was right. Decades later in the 1970s, astronomer Vera Rubin confirmed the same pattern on a smaller scale. She studied the rotation curves of spiral galaxies, measuring how fast stars orbit around the galactic center at different distances. According to Newton's laws, stars farther from the center should move slower, the way outer planets in our solar system orbit more slowly than inner planets. But that's not what Rubin found. Stars at the edge of galaxies were moving just as fast as stars near the center, sometimes faster. The only explanation was invisible mass, a halo of dark matter surrounding each galaxy, extending far beyond the visible edge, pulling on stars with its gravity, but emitting no light. Rubin's work provided the clearest evidence yet that dark matter wasn't a quirk of clusters. It was everywhere. Every galaxy, including our own Milky Way, is embedded in a cloud of dark matter, much more massive than all the stars combined. Think about that for a moment. Our galaxy contains roughly 200 billion stars. Billions upon billions of suns, each with their own potential for planets, for moons, for complexity. And all of it, every star, every planet, every atom of gas and dust is outnumbered 6-1 by something we can't see. Dark matter doesn't just exist, it dominates. But what is it? That's the question scientists are still trying to answer. It's not ordinary matter made of atoms. It doesn't interact with light, so it can't be dim stars or cold planets or clouds of gas. It's something fundamentally different. The leading theory suggests it's made of particles that don't interact with electromagnetic force, only with gravity. Physicists call them WIMPs, weakly interacting massive particles. They pass through ordinary matter, like ghosts barely noticing it's there. Experiments around the world are trying to detect dark matter directly. Deep underground, shielded from cosmic rays and background radiation, scientists have built detectors filled with ultra-pure substances waiting for a dark matter particle to collide with an atomic nucleus. Just one collision would be enough to prove its existence. But so far, nothing. The silence continues. And yet we know it's there. We can see its effects. Galaxy clusters bend light from objects behind them, creating gravitational lenses. The amount of bending tells us how much mass is present, and time after time the mass is far greater than the visible matter can account for. Dark matter's gravity shapes the universe's structure, pulling galaxies into clusters, clusters into superclusters, creating the cosmic web that stretches across the observable universe. Without dark matter, galaxies wouldn't exist. The gas that formed the first stars wouldn't have clumped together densely enough. The universe would be smoother, emptier, lifeless. Dark matter is the scaffolding on which everything visible is built, and it does this work silently and visibly without asking for recognition. Now, let's talk about dark energy. If dark matter is mysterious, dark energy is even stranger. It's not matter at all, it's something else. A property of space itself, perhaps. An energy field permeating the vacuum. A force that pushes rather than pulls. In 1998, two teams of astronomers were studying distant supernovae, using them as cosmic distance markers. They expected to find that the expansion of the universe was slowing down, gradually decelerating under the pull of gravity. But instead, they found the opposite. The expansion was accelerating. Galaxies weren't just moving apart, they were moving apart faster and faster. This discovery won the Nobel Prize in 2011, but it also opened a door to a deeper mystery. What could cause acceleration? Gravity pulls things together. It doesn't push them apart. Something else had to be at work. Something scientists had never accounted for. They called it dark energy. And the numbers are staggering. Dark energy makes up about 68% of the universe. Dark matter accounts for 27%. Ordinary matter, everything we can see and touch and measure, is only 5%. We live in a universe where we understand only a tiny fraction of what exists. Dark energy doesn't clump like matter. It's spread evenly through space, a constant pressure pushing outward. As the universe expands, more space is created, and with it, more dark energy. This creates a feedback loop. The more the universe expands, the more dark energy there is, which causes even faster expansion. It's a runaway process, and it's been going on for billions of years. In the far future, dark energy will dominate completely. Galaxies beyond our local group will recede so fast that their light will never reach us. The universe will become colder, darker, more isolated. Eventually, even atoms might be torn apart by the accelerating expansion, pulled into constituent particles by the relentless push of dark energy. Physicists call this the Big Rip. It's one possible fate of the cosmos, though it's trillions of years away. But let's return to the present. Right now, you're surrounded by dark matter. It's streaming through you constantly, billions of particles per second, passing through every cell in your body without interacting. You're also immersed in dark energy, the invisible pressure that's pulling the universe apart, and you feel none of it. You're oblivious to the forces that define the cosmos, the substances that make up most of reality. Here's a question to consider. If we only perceive 5% of the universe, how much are we missing? What else might be out there invisible and silent, shaping our reality in ways we can't detect? One of the most common misconceptions about dark matter is that it's like a cloud you could travel through and feel, but it's not. Dark matter is diffuse, spread out over enormous volumes. If you scooped up a cubic meter of space near Earth, it would contain only a tiny fraction of a gram of dark matter. It's not dense. It just adds up over galactic scales. The Milky Way's dark matter halo extends hundreds of thousands of light years, but at any given point, it's almost imperceptibly thin. Another misconception is that dark matter is a single thing. It might not be. There could be multiple types of dark matter particles, each with different properties. Or it could be something we haven't imagined yet, not particles at all, but something else entirely. Some physicists have proposed modifying gravity itself, adjusting the equations so that dark matter isn't needed. But so far, those theories don't match observations as well as dark matter does. Dark energy is even less understood. Some scientists think it's the cosmological constant, a term Einstein added to his equations, and later called his biggest blunder. Ironically, the cosmological constant now seems to describe dark energy perfectly. It represents the energy of empty space, a baseline energy that exists even in a vacuum. Quantum mechanics predicts this should exist, but the predicted value is wildly different from what we observe, off by a factor of 10 to the power of 120. That's not a small discrepancy. It's one of the biggest unsolved problems in physics. Other theories suggest dark energy is a dynamic field changing over time. They call it quintessence. If that's true, the fate of the universe could be very different. Instead of accelerating forever, expansion might slow down or even reverse. The universe could recollapse in a big crunch or settle into some equilibrium state. We don't know. We can't know not yet. But here's what we do know. Dark matter and dark energy are real. Their effects are measurable, repeatable, woven into the structure of the cosmos. They may be invisible, but they're not imaginary. They shape galaxies, drive expansion, determine the universe's fate. And they do it all in silence. There's something humbling about that. The universe operates on principles we barely grasp through mechanisms we can't observe directly. And it's been doing this for 13.8 billion years without needing our understanding or approval. The cosmos doesn't require us to explain it. It simply is. And maybe there's comfort in that. Maybe it's okay not to know everything. Maybe the silence of dark matter and dark energy isn't a failure of science, but a reminder that the universe is deeper, stranger, more complex than we can imagine, that there's always more to discover, always another layer beneath the surface. You're made of ordinary matter, the rare 5%. Atoms forged in stars, arranged into molecules, organized into cells, conscious and breathing and thinking. You're a temporary pattern in the small fraction of the universe that interacts with light. And yet, you exist within a larger framework held by dark matter's gravity, carried by dark energy's expansion, part of a cosmos that's mostly invisible. That's not a diminishment, it's a connection. You're not separate from the dark universe. You're embedded in it, shaped by it, part of its story. The silence that surrounds you isn't empty. It's full of presence, of influence, of forces working quietly to hold everything together, while simultaneously pulling it apart. So rest in that paradox tonight. You're held and released, anchored and drifting part of a universe that's mostly unknowable, but entirely yours to wonder about. You don't need to solve the mystery of dark matter. You don't need to understand dark energy. You can simply exist within their influence the way you always have, the way everything always has. The universe has been doing this since the beginning, balancing visible and invisible, known and unknown, silence and presence. And it's still here, still expanding, still creating complexity from simplicity. You're part of that. A small part, yes, but essential in your own way. Made of the rare matter that shines, surrounded by the common matter that doesn't. Both necessary, both real, both woven into the fabric of everything. And as we've journeyed through all these forms of cosmic silence, from the vacuum between stars to the invisible majority that shapes reality, we find ourselves returning to where we began, to the one place in all this vastness where silence and sound coexist, where the universe learned to listen to itself. There's a universe inside you, not metaphorically, literally. Your body is mostly empty space. Between the atoms that make up your cells, between the molecules that form your tissues, there are vast distances. If you could zoom in far enough, shrinking down to the scale of particles, you'd find that you're built the same way the cosmos is. Mostly void, mostly silence, held together by invisible forces shaped by fields you can't perceive. You are in the most fundamental sense made of the same nothingness that fills the space between stars. The difference is arrangement, organization. The way those scattered particles happen to come together for a brief moment in cosmic time to form something that thinks and breathes and wonders about itself. Tonight, let's explore that inner silence, the quiet spaces within you that mirror the quiet spaces without. Scientists estimate that atoms are 99.9999% empty space. The nucleus at the center is tiny, surrounded by a cloud of electrons that don't orbit like planets, but exist in probability waves smeared across space. The distance between the nucleus and the electron cloud relative to their sizes is vast. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be whispers of possibility dancing in the stands. Everything solid is an illusion. Your hand, the chair you're sitting on, the ground beneath your feet, it all feels solid because of electromagnetic repulsion. The electrons in your atoms push against the electrons in other atoms, creating the sensation of touch. But there's no actual contact, not in the way we imagine. Just forces interacting across emptiness, creating the feeling of substance where there's mostly space. You're not solid. You're a pattern of mostly nothing held in shape by forces too small to see. And within that pattern, there are layers of silence we rarely consider. Your brain, for instance, generates electrical signals constantly. Neurons firing, synapses connecting thoughts forming from cascades of chemical reactions. But you don't hear any of it. The most complex structure in the known universe operates in complete internal silence. No sound accompanies a thought. No noise marks a memory forming. Your consciousness arises from processes too subtle to detect directly happening in the quiet spaces between cells. A single neuron is separated from its neighbors by a tiny gap called a synapse, about 20 to 40 nanometers wide. That's billionths of a meter. Signals don't jump directly across. Instead, the sending neuron releases chemicals called neurotransmitters, which drift across the gap and bind to receptors on the receiving neuron. This process, the foundation of every thought, every emotion, every memory you have, happens in silence, trillions of times per second across billions of neurons without making a sound. Your brain weighs about 3 pounds and contains roughly 86 billion neurons. Each neuron can connect to thousands of others, creating a network of staggering complexity. Scientists estimate there are more potential neural pathways in your brain than there are atoms in the universe. And all of it operates quietly. Thoughts emerge without announcement. Consciousness arises without fanfare. The most miraculous process we know of self-awareness happens in the stillness between synapses. But let's go deeper. Down to the cellular level. Each of your cells is a miniature universe containing structures, processes, systems working in coordination. Mitochondria, often called the powerhouses of the cell, generate energy through chemical reactions. They were once independent organisms, bacteria, that merged with other cells billions of years ago in a symbiotic relationship. Now, they're part of you, producing the ATP that fuels every action you take. And they do it silently in thousands of cells, simultaneously keeping you alive without requiring your attention. Your heart beats roughly 100,000 times a day, 70 beats per minute on average, pumping blood through 60,000 miles of blood vessels. That's enough to circle the Earth twice. And most of the time, you don't notice. The heart works in the background, contracting and relaxing, maintaining rhythm, responding to signals from the autonomic nervous system. It's been doing this since before you were born. Your first heartbeat occurred when you were about 3 weeks old in the womb, and it hasn't stopped since. Billions of beats performed reliably quietly without conscious direction. Think about the silence of that. Your body runs itself, breathes without being told, digests without supervision, heals without instruction. You carry an intelligence within you that's older than language, older than thought, older than consciousness itself. The wisdom of 3.8 billion years of evolution encoded in your cells operating in the spaces you can't perceive. Your lungs exchange oxygen and carbon dioxide 20,000 times a day. Each breath brings in about half a liter of air, filtering through 300 million alveoli, tiny sacs, where gas exchange occurs. The surface area of your lungs, if spread flat, would cover about half a tennis court. And this process happens automatically managed by your brainstem responding to carbon dioxide levels in your blood. You can override it temporarily, hold your breath, or breathe faster. But eventually the body takes over. The silence beneath consciousness knows what you need better than you do. Scientists studying meditation have found something fascinating. When people enter deep meditative states, certain areas of the brain become less active. The default mode network responsible for self-referential thinking quiets down. The constant chatter of planning, remembering, worrying, imagining it softens. And in that softening, people report feeling more connected, more present, more at peace. As if the silence they've cultivated externally allows them to touch the silence that's been inside them all along. Your body is largely water. About 60% of your mass is H2O, water that was once rain, once ocean, once part of other living things cycling through the biosphere for billions of years. The atoms in your body are ancient. The hydrogen in your water was formed in the Big Bang. The carbon in your cells was cooked in the heart of a dying star. The calcium in your bones came from a supernova explosion. You're made of stardust, as Carl Sagan famously said. But you're also made of silence. The space between those atoms is the same space that fills the cosmos. Here's a thought experiment. If you removed all the empty space from your body, compressed all your atoms until they touched, you'd be about the size of a grain of sand. That's it. All of you condensed. Everything you are, every experience, every memory compressed into something almost invisible. The rest is emptiness. Organized emptiness, yes. Purposeful emptiness, but emptiness nonetheless. And yet that emptiness is essential. Without it, electrons couldn't move. Chemical bonds couldn't form. Life couldn't exist. The space within you isn't wasted. It's the canvas on which everything else is painted. Your DNA is another marvel of silence. Every cell in your body contains the same genetic code, about 3 billion base pairs of information. If you could unwind all the DNA in one cell and stretch it out, it would be about 2 meters long, but it's packed so efficiently that it fits inside a nucleus only 6 micrometers across. And most of the time, most of your DNA is silent. Only about 2% actively codes for proteins. The rest, once called junk DNA, serves regulatory functions, structural roles, evolutionary remnants. It's there, quiet, waiting. Scientists are still discovering what happens in that silence. Epigenetics has revealed that genes can be turned on or off without changing the DNA sequence itself, influenced by environment behavior, even stress. Your experiences literally shape which parts of your genome speak and which stay quiet. The boundary between you and the world is more permeable than it seems. There's a rhythm to your body's silence. Your circadian rhythm, the internal clock that governs sleep and wakefulness, operates on roughly a 24-hour cycle. Even without external cues, without sunlight or clocks, your body knows when to sleep. The suprachiasmatic nucleus, a tiny cluster of cells in your brain, coordinates this rhythm influenced by light exposure, but maintaining its own internal beat. You're a walking, breathing metronome, keeping time with the rotation of the Earth, synchronized with the cosmos without conscious effort. Sleep itself is a descent into silence. When you sleep, your conscious mind quiets, but your body is still active, still repairing tissue, consolidating memories, clearing metabolic waste from the brain. Scientists have discovered that during sleep, cerebrospinal fluid flows more freely through the brain, washing away proteins that accumulate during waking hours. It's a kind of internal housekeeping, performed while you're unaware in the silence of unconsciousness. Dreams happen in that silence too. The brain generates entire worlds, narrative sensations, all without external input. You hallucinate vividly every night, creating experiences that feel real in the moment, then often forget them by morning. The imagination that creates dreams is the same faculty you use during waking life, just unleashed, unfiltered, exploring possibilities in the quiet of sleep. Now, consider pain. Physical pain is a signal, a message from your body to your brain that something needs attention, but the signal itself is silent. Pain doesn't make a sound. It travels as electrical impulses along nerve fibers, crosses synapses, reaches the brain, and only then becomes conscious experience. The sensation you feel is your brain's interpretation, not a property of the injury itself. People with congenital insensitivity to pain, a rare genetic condition, can be injured without feeling it. The signals don't translate. The silence remains unbroken. This reveals something profound. Experience is constructed. Your brain takes silent signals and creates the rich, vivid world you inhabit. Colors, sounds, tastes, textures. They don't exist outside you. They're interpretations, translations of electromagnetic waves, pressure changes, chemical interactions into the language of consciousness. You live inside a simulation your brain creates, updated constantly by sensory input, but fundamentally internal. A private universe built from silence and electricity. And in that universe, you're alone. Not lonely necessarily, but alone in the sense that no one else can access your experience directly. Your thoughts are yours. Your sensations are yours. The silence inside your skull is impenetrable from the outside. We communicate through symbols, words, gestures, trying to bridge that gap. But we can never fully cross it. Each of us is an island of consciousness, surrounded by the void, reaching out through sound and light and touch, hoping to connect. Yet, paradoxically, we're all made of the same stuff. The atoms in your body have been part of countless other beings. The carbon in your hand might have once been in a tree, a deer, an ancient human. We're constantly exchanging matter with the environment, breathing in air that others have breathed, drinking water that's cycled through the biosphere for eons. In that sense, we're not separate. We're temporary arrangements of matter that's been rearranging itself for billions of years. The silence within you is the same silence that fills the universe. The space between your atoms is the same space that separates galaxies. You're not isolated from the cosmos. You're continuous with it, made of it, part of its ongoing story. So, tonight as you settle into rest, remember this. Your body knows how to be silent. It's been practicing for as long as you've been alive, longer even. The cells remember. The atoms remember. You carry within you the quietness of stars, the stillness of space, the patient rhythm of evolution. You don't have to make yourself quiet. You already are beneath the noise. You just have to remember, to notice, to let the silence you've been searching for outside reveal itself within. Your heartbeat slows, your breathing deepens, the electrical storms in your brain begin to settle, and in that settling, you touch something ancient, something that's been with you always, the silence that holds you together, the space that lets you be. Rest there, in the emptiness that is somehow full, in the quiet that speaks without words, in the vast, gentle nothingness that makes everything possible. And as the silence within begins to mirror the silence without, as the boundary between inner and outer space dissolves into the gentle rhythm of breath and heartbeat, we arrive at the place where all journeys end and begin again. We've traveled far tonight, through the vacuum between stars where sound cannot exist, past the ancient whisper of the cosmic microwave background, still echoing from the universe's infancy. We've drifted among dead stars, and frozen galaxies felt the weight of light years stretching time itself, stood on airless worlds where silence is absolute. We've reached the edge of the observable universe where information stops touch the invisible majority of dark matter and dark energy, and discovered that even within our own bodies, we're made mostly of emptiness held together by invisible forces. And now we return, back to Earth, back to the one place in all this vastness where silence and sound exist together, where the universe learns somehow to listen to itself. From space, Earth looks impossibly fragile, a thin blue shell of atmosphere wrapped around a rocky sphere, suspended in the cosmic ocean. That atmosphere, just a few miles thick, thinner than the skin of an apple relative to its size, is what makes everything different. It's the barrier between silence and sound, between the void and life. Carl Sagan wrote about this in 1994, reflecting on the pale blue dot image. He said, "Look again at that dot. That's here, that's home, that's us. Everything you've ever known, everyone you've ever loved, every sound you've ever heard, it all happened on that dot. In that thin envelope of air where molecules are dense enough to carry vibrations to transform motion into sound to make communication possible. But even here on this noisy planet, silence waits. It's there beneath the surface noise, in the spaces between heartbeats, in the pauses between breaths. The same silence that fills the cosmos fills you. You carry the void within. You are fundamentally more emptiness than substance. And there's something profound in that. Scientists studying meditation and sleep have discovered fascinating parallels between inner silence and cosmic silence. When the brain quiets during deep meditation or sleep, certain frequencies dominate delta waves around 0.5 to 4 Hz, slow oscillations that synchronize across the cortex. Dr. Matthew Walker, a sleep researcher at UC Berkeley, describes this as the brain taking out the trash, clearing metabolic waste accumulated during waking hours. The glymphatic system becomes 10 times more active during sleep, flushing toxins from neural tissue. But it's more than just cleaning. Sleep is when memories consolidate, when learning solidifies, when the brain reorganizes itself. Dreams occur during REM sleep, when the brain is nearly as active as during waking, but disconnected from sensory input and motor output. You hallucinate vividly, creating entire worlds from nothing, experiencing emotions and narratives that feel completely real in the moment. It's the closest most of us come to creating something from the void. Dr. Walker's research shows that sleep deprivation affects nearly every system in the body. After just one night of reduced sleep, learning and memory decline by 40%. Emotional regulation fails. The amygdala, responsible for fear and anxiety responses, becomes 60% more reactive. Cardiovascular health suffers. Immune function drops. Even a single hour of lost sleep, as happens during daylight saving time transitions, correlates with a measurable increase in heart attacks the following day. Sleep isn't optional. It's not time wasted. It's essential maintenance, as fundamental to life as breathing, and it requires silence. Not necessarily external silence, the world will always have noise, but internal silence, the quieting of thought, the release of the day's concerns, the willingness to let consciousness dissolve into something softer, darker, more diffuse. There's a rhythm to this. Your circadian clock, governed by the suprachiasmatic nucleus in your hypothalamus, tracks the day-night cycle even without external cues. Light exposure, particularly blue wavelengths, suppresses melatonin production, keeping you alert. As evening approaches and light fades, melatonin levels rise, body temperature drops slightly, and sleepiness increases. This is ancient biology synchronized to Earth's rotation, connecting you to the same cosmic rhythms that govern tides and seasons. But modern life disrupts this. Artificial light, especially from screens, tricks your brain into thinking it's still daytime. Caffeine with a half-life of 5 to 6 hours blocks adenosine receptors that signal sleepiness. Stress and anxiety keep the sympathetic nervous system activated, maintaining alertness when rest should come. We've become disconnected from our own biology, fighting against rhythms that evolved over millions of years. And yet, the body knows. It remembers. Given the chance darkness quiets safety, it will find its way back to sleep. The process is automatic, ancient, reliable. You don't have to learn how to sleep. You already know. You've been doing it since before you were born, since your first heartbeat in the womb. Tonight you can trust that knowledge. You can let go of the need to control, to monitor, to stay vigilant. The universe has been practicing this for 13.8 billion years, existing without effort, continuing without conscious direction, holding everything together through forces that work silently, patiently, without requiring acknowledgement. Your body is the same. Right now, your heart is beating about once per second, circulating 5 liters of blood through 60,000 miles of blood vessels. Your lungs are exchanging oxygen and carbon dioxide automatically regulated by chemoreceptors that monitor blood pH. Your digestive system is processing food. Your immune system is patrolling for threats. Your liver is filtering toxins. Your kidneys are balancing electrolytes. None of this requires your attention. It's all happening in the background, in the silence beneath consciousness. And in a few moments, or perhaps already, your brain will begin the transition into sleep. The thalamus, which relays sensory information to the cortex during waking, will start to close the gates, reducing external input. The reticular activating system, which maintains alertness, will quiet. Sleep spindles, brief bursts of brain activity at 12 to 14 hertz, will begin appearing in your EEG, marking the transition into stage 2 sleep. These spindles are thought to protect sleep from disruption, creating a shield against external stimuli. Then, if conditions are right, you'll descend into slow-wave sleep stage 3, where delta waves dominate and consciousness fades almost completely. This is the deepest, most restorative sleep, where growth hormone is released, where tissues repair, where the immune system strengthens. Time becomes strange here. Minutes can feel like hours or vanish entirely. Dreams, if they occur in this stage, are vague, conceptual, more like impressions than stories. Later, you'll cycle back up through lighter stages and into REM sleep, where the brain becomes active again, where vivid dreams emerge, where emotional processing happens. Your eyes will move rapidly behind closed lids, your muscles will be paralyzed to prevent you from acting out dreams, and your heart rate and breathing will become irregular. This is where nightmares occur, but also where creativity flourishes, where problems are solved in surprising ways, where the mind explores possibilities without the constraints of waking logic. You'll cycle through these stages 4 to 6 times tonight, each cycle lasting about 90 minutes. Early in the night, slow-wave sleep dominates. Later, REM periods grow longer. This architecture is conserved across mammals, suggesting it's deeply important, refined by evolution over millions of years. Sleep isn't one thing. It's a symphony of states, each with its own purpose, each essential to the whole. And through it all, a kind of silence prevails. Not the silence of the void, but the silence of restoration. The quiet hum of maintenance, of healing, of reorganization. Your conscious mind might create stories, dreams, fragments of experience. But beneath that, the body is doing its work in stillness in the dark without fanfare. This is what the universe has been teaching us all along. That silence isn't emptiness. That stillness isn't absence. That the most important processes often happen in the quiet spaces, unnoticed, unheralded, but absolutely essential. The stars burn silently for billions of years. Galaxies evolve without announcement. Black holes curve space-time without sound. and your body repairs itself night after night in the gentle darkness of sleep, asking nothing of you except that you let it do its work. So, let go. You've carried enough for one day. The thoughts can wait. The worries can wait. The plans and problems and questions that will still be there in the morning. But right now, you can rest. You can sink into the silence that's been here all along, the silence that holds everything together, the silence that makes space for what comes next. The universe doesn't need you to understand it. Your body doesn't need you to manage it. They've been doing this long before you were aware, and they'll continue long after you wake. All you need to do is trust. Trust the process, trust the darkness, trust the silence. Because silence isn't the end of something. It's the beginning. It's the foundation on which everything else is built. Sound needs silence to have meaning. Light needs darkness to be visible. Waking needs sleep to be sustainable. And consciousness needs rest to remain clear. You are not separate from this. You are part of the pattern. A temporary arrangement of atoms and energy and consciousness held together by forces you can't see, connected to a universe that's mostly empty space, but somehow creates stars and planets and life and thought and wonder. You are the cosmos experiencing itself, and right now, this part of the cosmos needs sleep. So breathe, let the air fill your lungs, and then release. Feel the weight of your body against whatever supports you. Notice the temperature of the air, the softness of fabric, the gentle pressure of gravity holding you to this planet that's hurtling through space at 67,000 miles per hour, orbiting a star that's circling a galaxy that's moving through the universe. And yet, here right now, everything is still. The same silence that fills the space between stars fills the space between your atoms. The same patience that governs cosmic evolution governs the healing of your body. The same forces that hold galaxies together hold you together. You're not isolated from the universe. You're continuous with it, made of it, part of its ongoing story. And tonight, this moment of the story is about rest, about letting go, about trusting that the universe knows what it's doing, because it's been doing it for 13.8 billion years and hasn't failed yet. The sun will rise tomorrow. The earth will keep turning. The atoms in your body will keep dancing their quantum dance. And you, having rested, will wake to meet another day. But that's tomorrow. Right now, there's only this, the softness, the darkness, the gentle, patient silence that cradles all things. Sleep well, friend. Let the cosmos keep its secrets for now. Let the questions wait. Let the universe hold you in its vast, quiet embrace. You're safe here. You always have been. And when you wake, the stars will still be there, shining silently, waiting to tell you more stories. But for now, just rest. The silence is here. It's always been here. And it's yours whenever you need it. Good night. Thank you for traveling with us tonight through the silent universe. We hope this journey brought you peace, wonder, and perhaps a new appreciation for the cosmic quiet that surrounds and fills us all. If these stories helped you find rest, we'd love to continue exploring the universe's mysteries together. There are so many more tales waiting to be told softly about the whispers of distant worlds, the slow dance of time, the hidden patterns that connect all things. Until we meet again in the next quiet night, may you carry this cosmic stillness with you, and may your dreams be as vast and gentle as the space between stars.